let's put it all together. Okay, so the way we're going to do this is we're going to start with a point charge and dry erase marker. So I've got a point charge of 65 coulombs sitting out in empty space. The first question, what is the voltage at a point 22 meters away? I'm going to put all of my variables here. First thing I want to know is voltage. Next, I'm going to set up a conductor going through here. I'm going to want to know the resistance of that conductor. After that, I'm going to want to know what the current will be through that conductor. Then I want to know what the power will be. I want to know what the force will be if I place another charge at this point. And I want to know how long it would take for the charge placed at this point to travel over to this point. Okay, so this is a lot. I'm looking at 1, 2, 3, 4, 5, 6 different variables. I'm starting with very little information. We're going to get more as we go on, but mostly only in the resistance portion. So this video is primarily going to be to show you how to put all of the stuff we've learned so far in electrodynamics together in a comprehensive way. So, what's the voltage at a point 22 meters away? Well, voltage is found, let's put it over here, let's start up in this corner. V is found using K, Q over R. It is also equal to F D over Q. Alright, so we're going to use this definition. That's going to be the thing that helps us. KQ over R. Well, we've got Q, we've got R. So, our K is going to be 9E9, like always, times the Q of 65 coulombs. Remember, voltage is a scalar quantity, so it doesn't matter if this is negative or positive, whatever. It really doesn't matter. And then 22 meters. Then let's calculate that. Okay, the voltage I get is 26.5. Round that to 26.6 E9. Okay, voltage 26.6 E9 volts. Resistance. In order to find this, I do need to know some things. We're going to say that this is a copper wire being placed between these 2 points. Okay. This is a copper wire. The resistivity of that copper wire is going to be 1.72 E negative 8. 1.72 E minus 8. And then we need to know the area. The area is going to be 5.24 millimeters squared. Ooh, millimeters squared. We need that in meters squared. So we need to convert millimeters to meters. Okay, so got a millimeter squared, which would be millimeter times millimeter. Well, that's not even an M. Okay. In order to convert that, I'm going to take my 5.24. I'm going to need another conversion of a millimeter to a meter. There are 1,000 in one. And I'm going to need to do that twice. Okay. Alright, and that'll cancel out both of my millimeters and give me meters squared. So 5.24 divided by 1,000 divided by 1,000. So that will be divided by 1,000,000. This is going to be very small numbers. So we'll just rewrite this as 5.24 E negative 6 meters squared. Okay, this resistance is going to be very small. Alright, so my resistance will be R equal, let's do it over here. all over the place tonight. R equals rho L over A, which is going to be 1.72 e negative 8 times 22 divided by 5.24 e negative 6. We get 72 e negative 3 ohms. That is very small. All right, now we need to know current. What will be the current as we travel this way? Well, that's nice and easy. We can just use Ohm's law to find that. Ohm's law is just going to be V equals IR. Rearrange that because we have voltage, we have resistance. So it's going to be I equals V over R. Okay, V was 26.6 E9 volts divided by 72 E negative 3 ohms. So this is going to be a very large number. That gets me 369 E9. That's going to be amps. Okay. 369 E9 amps. And then I need power. So power, much easier to find. Power is going to be voltage times current, which is going to be 26.6 E9 times 369 E9. It's going to give me a 9.8 E21 watts. Power is 9.8 E21 watts. Okay. So, now, force. In order to do the force, I need another charge. So I'm going to say a +8 charge. At this point, I'm placing a +8 charge. +8 coulombs. What will be the force that that charge experiences? Well, for that I'm going to use my second definition for voltage. So that's going to be V equals FD over Q. I'm going to solve this for force. So that's going to rearrange to say VQ over distance equals F. In order to do that, plugging in my variables, my voltage, 26.6 E9 times my charge of 8 divided by my distance of 22. And that will get me 9.67 E9 newtons. All right, last but not least, time. Now, how the heck are we going to find time? How long, what we're asking is, how long would it take a +8 charge to travel this distance to the first charge? Well, we've got a current of 369 E9 amps. Let's erase some of this. In order to find the time, we need to look at our definition of current. Current is Q over T. This will actually be a lot easier than it looked. So, current I have, that's going to be 369 E9 equals the charge, which is 8 coulombs divided by time. So time is going to equal 8 divided by 369 E9. It'll be very, very tiny. So our time gets 21.7 e negative 12 seconds. It takes 21.7 e negative 12 seconds to travel through this wire. Here we go. So we've put all of our concepts back together. We've used all of them to solve one problem. This is what our test is going to look like. So I'm going to give you a couple practice problems like this, and then either Monday or Tuesday or whenever we're ready to go, whenever we're comfortable with it, confident enough in our ability, then we'll go ahead, I'll send you a test. It'll just be a Google form. You'll fill that out, and then we'll go from there. All right? You can do this.